ideally, I'm going to just create a bunch of power series with some information that's randomly created by Excel. Hopefully you can start to see some patterns develop. And at the very end, after we make a lot of different problems, we're going to talk about what it is that I'm looking for that allows me to create these series. Okay, I'm not going to show a lot of work in this video. The reason why is because it kind of defeats the purpose. I want to just crush through as many problems as possible in this short amount of time. But I'll also then be posting a write-up of all the problems that I do. So all the problems that I get through, you will see a link next to the video on your Blackboard page that's going to have a PDF scan of the actual me showing that all my results are accurate. We're going to do the ratio test for every single one of these power series that I create to see and make sure that I am correct. Okay, that's the goal. Now, there's three different ways that we're going to make power series. The first one, I'll be given the radius and the center, whether it converges on the left bound, it converges on the right bound. I'll then make a power series, and every time I hit F9, it'll compute a new random parameter. The second way is I'll be given the interval of convergence. So what's the left bound of the interval of convergence, what's the right bound of the interval of convergence, and whether it converges at that endpoint. So whether I'm closed or open at any of my endpoints. And then finally, we're going to go the opposite direction. I have here like a series where I've described some parameters like R, some sort of polynomial, and then a center. And I can randomly generate those parameters as well. And then I'll actually give you the interval of convergence. So I'll compute the other way. That's our goal for today. Okay, so let's just go ahead and begin. So our first problem, so number 1, my radius here, capital R, is 1/5, and A equals 3. Okay, so my sum is n equals 1 to infinity of 5 to the n times x minus 3 to the n, and then it converges on the right side, so I'll multiply by negative 1 to the n over n. All right, that is my first series. Let's move this a little bit. Okay, next. Problem 2. Radius is equal to 2/9. Center is equal to 1, and it converges at neither side. So I'm just going to have the sum from n equals 1 to infinity of 9 to the n, x minus 1 to the n, over 2 to the n. Done. All right. Number 3. My radius equals 3/2. My center is negative 5. So I'm going to have a sum from n equals 1 to infinity of 2 to the n times x plus 5 to the n, all over 3 to the n. It doesn't converge at either side, so we'll leave it there. All right, number 4. We'll reset this. Radius equals 4 is not super interesting. All right, number 4. My radius equals 2. My center equals 4, and it converges on the left. Okay, so I'm going to have the sum from n equals 1 to infinity, x minus 4 to the n, over 2 to the n times n to the first power. Number 5. Radius is equal to 4/3. My center is equal to 1. Converges on the right hand side. So I'm going to sum from n equals 1 to infinity of 3 to the n, x minus 1 to the n, negative 1 over n, 4 to the n, times n. Number 6. All right. My radius equals 2. My center is -2. That converges at neither the left nor the right. Sum of the sum from n equals 1 to infinity of 1 over 2 to the n times x plus 2 to the n. Okay. Oh. All right. Let's try to do 3 more. Number 7. R again is 3/2. My center is equal to -3. Converges on left-hand side. So I'm going to get the sum from n equals 1 to infinity of 2 to the n x plus 3 to the n all over 3 to the n times n. Number 8. Radius equals 1/4. Center equals 2. Converges on the right hand side. So I'm going to get the sum from n equals 1 to infinity, 4 to the n, x minus 2 to the n, times -1 to the n, all over n. All right, let's do 2 more. Okay, number 9. Radius is equal to, what is that, 8/3? Yes, 2 is 6/3 plus 2, okay, 8/3. And then the center equals -5. Converges on the left-hand side. This is going to be the sum from n equals 1 to infinity, 3 to the n, x plus 5 to the n, over 8 to the n times n. And then finally, in this set of problems, we've already had radius equals 2 a whole bunch. Let's do this. There we go. All right, this is a good problem. Radius equals 5. Center equals -1. Converges at both endpoints. Sum from n equals 1 to infinity of x plus 1 to the n over 5 to the n times n squared. And there we have it. So in just under 7 minutes, we've done 10 power series. Okay, great. Now, let's see instead if we're given the bounds. All right. So now problem number 1, we'll just use this one. It looks like my interval is from 1 to 2 2/5. Conversion at both endpoints. So I need to find the center and radius. So first, I'm going to convert this. This is from 1 to 12/5, which is 5/5 to 12/5. So it looks like my center is going to be at 17/10, which means my radius is 7/10. Okay, So then my series is the sum from n equals 1 to infinity of 10 to the n x minus 17 over 10 to the n all over 7 to the n times n squared. All right, number 2. This looks like it's open 5/6 to 24 plus 7, 31/12. Open on both. Okay. So let's just convert these to the same thing. So this is 5, this is 10/12 to 31/12. Okay. So my radius is going to be 21 over 24. And then my center, it looks like, is going to be 41 over 24. Okay, so now my series is n equals 1 to infinity 24 to the n over 21 to the n times x minus 41 over 24 to the n. Alright, so let's do another one. So now my left bound is 1/5 and it does not converge. Oh, this is going to be fun. My right bound is 44 out of 45 and it does converge. Okay, so again I'm going to rewrite these. So this is 9 out of 45 to 44 out of 45, including on the right bound. So then my radius is going to be 44 minus 9 over 90, which is what, 35 over 90, which is 7 over 18. Okay, so my radius is 7 over 18, which means my center A is 1/5 plus 7 over 18. Sure. Which is 18 over 90 plus 35 over 90. Which is 51 over 90. No, 53. That doesn't make any sense. There you go. 53 over 90. Okay. So A is 53 over 90. Radius is 7 over 18. So this is going to be the sum from n equals 1 to infinity of 18 to the n over 7 to the n times x minus 53 over 90 to the n. I want my right endpoint to converge, so I'm going to multiply by -1 to the n all over n. So if I want to rewrite this in a little more clearer fashion, 18 to the n over 7 to the n. Alright, so let's do 2 more in this vein. I don't want to do 2 over 63. There we go. My left bound, so I'm going to get 2/3 to 11/3, inclusive on the right side. So my radius is going to equal 9/6. My center then is going to be 13 over 6. So I'm going to have the sum from n equals 1 to infinity, 9 to the n, x minus 13 over 6 to the n, all over 6 to the n. And then I want it to converge on the right endpoint, so I'll have it as negative 1 to the n over n. Sometimes you might see this rewritten is, let's multiply so this is going to be the sum from n equals 1 to infinity of 9 to the n. I want to multiply everything by 6 on the inside, which means I need to multiply again by an extra 6 to the n in the denominator. Alright, this way there's no fractions inside with the 6x minus 13 to the n. I don't usually write it that way because I just like to see x minus my center, but just in case you might see those extra terms. Anytime the multiple in front of the 6 isn't a 1, essentially what it's doing is just obfuscating what the center is. Alright, let's do one more example. Okay. So 5, they're both convergent now, so it looks like I'm going from 9/10 to 13/10, both inclusive. So radius equals 2/10, which equals 1/5. My center A is going to equal 11/10. So I'm going to have the sum from n equals 1 to infinity of, we simplified this to 1/5, so this is going to simplify down to 5 to the n times x minus 11 over 10 to the n. And then I want it to converge at both endpoints, so I'm going to put it over n squared. And there we go. Alright, so if we're given the bounds, alright, if we're just given the interval of convergence, we can make a series that has that. We just take the right bound minus the left bound, divide by 2, that's our radius. The left bound plus the radius is going to be our center. And we can use our nice little formula that we explore in the next section. Okay, so finally, how do I get the radius of convergence, or how can I look at the interval of convergence? Just from the formula itself. That's our last little bit. So let's take a look at that. Okay, so now here, r equals 2/7, a equals -4. My value, my power of p is going to be -2 to the 1, -2 plus 1/3, which is -7/3. And then it doesn't matter, but I'm going to add an extra r to the end. So my theorem, or my series rather, my series looks like 2/7 to the n, x plus 4 to the n, times -1 to the n, all over n to the 7/3. Okay? Well then, my radius is going to be 7/2. My center is going to be -4. Alright? The sum from n equals 1 to infinity of -1 over n to the 7/3, and the sum from n equals 1 to infinity of just 1 over n to the 7/3 both converge. Alright, those both converge. So I'm going to include both of my endpoints. So this is going to be -4 minus 7/2 to -4 plus 7/2. And there we go. I am done. Alright, let's do one more. Let's do two more. Alright, r equals 2/3. Oh, this will be an interesting one. So let's give ourselves some space. So my little r, not my radius, my little r is going to be 2/3. My a is equal to -3. I'm going to multiply that by 1 over n. And I'm going to multiply by -1 to the n over n. Okay. So according to my little formula, alright, that's going to be the sum from n equals 1 to infinity of 2/3 to the n, x plus 3 to the n, times -1 to the n over n. Alright, so my radius is going to be 3/2. My center is going to be 3. Alright, I'm going to diverge on my left endpoint, which is 3 minus 3/2, and I'm going to converge on my right endpoint, which is 3 plus 3/2. There we go, it's my interval of convergence, just looking from the series. We can test this if we want. Let's look at what happens when x equals 3 minus 3/2. Well, sorry, this is -3. I just said my center is up there, so -3. So if x equals -3 minus 3/2, then x plus 3 equals -3/2. So x plus 3 to the n is -3/2 to the n. So 2/3 to the n, x plus 3 to the n is equal to 2/3 to the n times -3/2 to the n, which is -1 to the n. So my series just becomes n equals 1 to infinity of -1 to the 2n over n, which is the harmonic series, which diverges. So it looks like we did a pretty good job. Okay, so what I'm doing, and I'll adjust here, when I do all these power series in my head, all I'm looking at in my mind, alright, is I parameterize the entire series. So I break the series down into some number to the n. This little r is going to be 1 over my radius. So my radius is the reciprocal of this little r. This x minus a is always the center of my interval. Okay? And this n to the p, these other parts, that's what's going to determine just the endpoint convergence. If it's split, see here where it says converges on the left, converges on the right, well then I'm looking for something that is going to be conditionally convergent. Okay? Because I expect in my power series to one side to always alternate. this -1 to the n, alright, is going to flip whether it's the left side converging or the right side converging if they're different. Okay, if the p is big enough, so my power on p, if we look, say in example 1 here, my n was to the 7/3, well, that doesn't matter. Both sides are going to converge because of by the p-test. Okay, so that power on n is really going to determine whether one side converges or both sides converge or no sides converge. Okay, and this is kind of how I break it down. I've sort of parameterized all the series. So the numbers, the number that you see, the number to the n in the power series is going to be the reciprocal of my radius. The x minus a, the a is going to be my center of the radius, or the center of my interval. My bounds, every single one of my intervals is going to be a minus r to a plus r. And then what happens at the endpoints, I just use my previous chapters. Okay, we're using the alternating series test, we're using the p-test, whatever we have to determine the endpoint convergence. So that's how I break it down. I hope this was useful for you. I will post the written notes for all the problems that we did here.